What if I told you that something on Mars is behaving exactly the way living organisms behave on Earth, and NASA scientists genuinely do not have a clean explanation for it? Not a theory, not a guess. An actual scientific mystery that has divided some of the brightest minds on the planet for over 2 decades. Stay with me, because this one will change how you think about our solar system forever. Mars is supposed to be dead. That's what we were taught. A cold, barren, radiation-blasted rock with no atmosphere worth speaking of, no liquid water, and absolutely no business producing anything interesting. But then something happened that nobody expected. Methane showed up. And not just once. It showed up, disappeared, came back, spiked dramatically, then vanished again, following patterns that make no geological sense, and that, disturbingly, mirrors something very familiar here on Earth. Let's slow down and get precise, because the details here matter enormously. In 2003 and 2004, ground-based telescopes on Earth detected methane in the Martian atmosphere at concentrations of about 10 parts per billion. That sounds tiny, but on Mars, that number is enormous. Methane should not survive long on Mars. Ultraviolet radiation from the sun breaks it down within roughly 300 to 600 years. So if methane exists there today, something is actively producing it right now. That's the key word, actively. Then the Curiosity rover landed in Gale Crater in 2012, and this is where things got genuinely strange. Curiosity measured background methane levels hovering around 0.4 parts per billion, which was already puzzling. But in June 2019, something extraordinary happened. Methane levels inside Gale Crater suddenly spiked to 21 parts per billion. That is a spike of more than 50 times the background level, appearing almost overnight. NASA scientists were so shocked they held an emergency weekend meeting. Then within 48 to 72 hours, the methane almost completely disappeared again. Gone. As if something exhaled and then stopped. Here is where the controversy explodes. The European Space Agency's Trace Gas Orbiter, one of the most sensitive methane-detecting instruments ever sent to another planet, has been orbiting Mars since 2018, and it has detected effectively zero methane from above. None. But Curiosity on the ground keeps finding it. Two spacecraft, both looking at the same planet, getting completely opposite results. Scientists have been arguing about this for years. Some say there's an instrument calibration issue. Some say the methane is extremely localized near the surface and disperses so fast that the orbiter simply cannot catch it. Neither explanation is fully satisfying, and that tension is precisely what makes this story so important. Now here's the part that should stop you completely. On Earth, roughly 90 to 95% of all atmospheric methane is produced by biological activity. Living organisms, bacteria, archaea, animals digesting food, decomposing organic material. The remaining small percentage comes from volcanic activity, hydrothermal vents, and a geological process called serpentinization, where water reacts with certain rocks and produces methane as a byproduct. Both biological and geological explanations are technically possible on Mars. But here is what nobody can easily explain: the spikes. Random geological processes tend to be relatively steady. They don't suddenly explode 50-fold and then vanish in 48 hours. Biological organisms, however, respond to their environment. They become more active in warmer conditions, in seasonal cycles, during specific times of day or night. And that is exactly what Curiosity's data shows. The methane spikes appear more frequently during warm Martian summer afternoons. That pattern has a name in biology. It is called diurnal and seasonal metabolic variation. Scientists at the German Aerospace Center published research suggesting that when surface temperatures rise on Mars, methane trapped in ice or soil structures called clathrates could be released in bursts. That's a real geological mechanism, and it's worth taking seriously. But other researchers, including some from NASA's Jet Propulsion Laboratory, point out that the volume and timing of the spikes don't cleanly fit that model either. We are genuinely in a situation where no single explanation covers all the data. What makes this even more layered is what we know about ancient Mars. Satellite imaging and rover data confirm that Mars had liquid water on its surface between 3 and 4 billion years ago. Rivers, lakes, possibly even a northern ocean covering a third of the planet. Where there was water on Earth, life found a way. Every single time. Deep ocean vents, volcanic rocks, acidic hot springs, frozen Antarctic ice, life adapted and survived. If microbial life emerged on ancient Mars during that wet period, could it have retreated underground, surviving near subsurface liquid water that radar data from the Mars Express orbiter suggested exists beneath the southern polar ice cap in 2018? Could those organisms still be metabolizing today, producing methane as a metabolic byproduct, releasing it through cracks and fissures when conditions are right? Nobody is claiming that's proven, but nobody can rule it out either. And that is the most honest and important thing science has said about Mars in recent memory. The upcoming NASA Mars Sample Return mission and ESA's Rosalind Franklin rover, scheduled for launch later this decade, are being designed specifically to address questions like this. The instruments are sharper, the methods more targeted, and the scientific community is treating the methane question with full seriousness. Mars is not simply a dead rock we can file away. It is an active, complex, poorly understood world that keeps producing data that contradicts what we thought we knew. The methane spikes are not a footnote. They may be the most significant signal we have ever received from another planet. If you found this genuinely mind-expanding, follow this page right now, because we go deep on the real science, the real controversies, and the real questions that keep researchers awake at night. So here is what I want to know from you. If those methane spikes turn out to be biological in origin, how does that change your understanding of life's place in this universe? Tell me below.